partner, and we're delivering 4 sessions this week as a part of this online event. If you haven't already, you can register for the full event, in addition to share this with others. And so you can use the provided on-screen access for additional sessions. Also, make sure to wait till the end because I have a link for you all that you can show that you had participated in AI Skills Fest via a badge. So again, welcome to today's session that I'll be doing Code Smarter, Not Harder with GitHub Copilot. And my name is Alan Conway. I am a principal consultant and trainer here at Xebia in our Microsoft Services line. I have over 25 years experience exclusively as a software engineer, consultant, and trainer, running the stack of .NET, cloud development, web development, now getting into AI envisioning and enablement. Very excited about the content that I'm bringing you here today, again, as a hands-on engineer and consultant. Some of my professional contact information, and also I am a Microsoft MVP in .NET and web and a Microsoft certified trainer. Very good. All right. Make sure everybody's permitted in here, and we will continue rolling on. So, what are we going to look at today? Well, we're going to take a look at a practical look again about how to leverage GitHub Copilot effectively. And specifically, we'll look at one of my repositories that will emulate if you're being placed on a team, you need to get familiar with code, add features, maybe modernize some legacy code. So again, we're not here to prove that Copilot can write code. We know that. Most of us already know that. The real question is how to use it effectively without losing your quality, context, or control. So again, we'll look at a kind of a realistic developer workflow, and then I'll show you along the way how to provide the best context that you can, use patterns and practices. We'll improve the testing quality. Again, we'll look at some real scenario cases that you might run into as well. We want to be able to leverage it in its best abilities so we can take it to that next step as a professional developer. So let's dig right into some of the main areas that you will pivot between when you're working with GitHub Copilot. Now, obviously, there is a lot of avenues that you can go down with GitHub Copilot for niche scenarios, whether you're using specialized agents, creating your own instructions and such. But the primary time that you'll want to learn and understand how to leverage properly and well are the modes that are available within GitHub Copilot, that being ask mode, agent mode, and plan mode. And of recent, because of how GitHub Copilot has changed its billing, knowing these and using them properly is probably at its utmost importance as it ever has been, rather than just kind of wastefully being in one mode or another. So starting with, our ask mode, which is quite powerful on its own, because we don't need to necessarily execute on code immediately. So this is our conversational, asking questions. Oftentimes we do. We have to get oriented with a code base, with a set of files, what we're doing, asking technical hard skills questions about a stack, language, unfamiliarity, learning, all of those sorts of things. It's best for that kind of quick conversational and continued conversation within a thread. Now, one of the things I want to note here is that the nice thing is you can toggle between these different modes pretty fluidly without disrupting your communication. Not all AI tooling, when you jump outside of GitHub Copilot, behaves like that. Sometimes simply going into and toggling modes would disrupt that, but in this case, it's not. If I need to go from ask mode to agent or from plan to agent, you can do that pretty freely. When you talk about, I'll jump over to the right-hand side in plan mode. When we're in plan mode, this is the next level of ideating through something that you want to do. Again, you're not ready to execute code. And even in ask mode, when you're asking questions, it may start throwing you code samples directly in GitHub Copilot. You're not ready for that. This is like your virtual whiteboard. You need to think through what you're going to do. This could be from the smallest of tasks to entire applications. And it is healthy to go through plan mode and iterate through until that plan is refined and you have it in a state that you're able to then start executing on it. It will give you options within plan mode to say, do you want to start implementing this and which flavors of that? Or like I mentioned, we could toggle to the other modes like agent mode and do that ourselves. Then when you look at agent mode, this is your autonomous or semi-autonomous worker. It can also take that information, whether you had been asking questions or plan mode, or just directly started with it because you're ready to execute. It can do multi-step tasks, run commands directly in the IDE as needed to help you go along, whether that's builds, tests, looking at errors, looking at your code, finding context, semantic meaning throughout your code base. Lots of things that it has the power to do. But it also can, keeping it, lively for what we are here in June 2026 with, again, the updated billing modes and such. We want to use it to our best and not just, and we want to use it efficiently and not use it unnecessarily. I'll try to keep an eye and see if anybody has any questions while I'm looking at this, but I think right now we'll continue rolling on. So what we're looking at here is code context. Now, this is fundamental in doing well with GitHub Copilot inside of your code base. All right, so pointing Copilot at the exact potential files that you might be using is a helpful best practice. Now, you might say to me, hey, Alan, if I use agent mode, maybe I can just describe what I'm using again in a semantic meaning, and it will find what's needed. And that's right. But when you talk about things like latency and efficiency, not just from a billing standpoint, but yielding what output is best for what you want, which means accuracy. I want something done with code. I want something fixed. I want something updated. This is important to provide the proper context to your best of your ability. And there's multiple ways that you can do this, from concretely referencing a file or dropping it in or adding it in. Again, agent mode, when we get into that, is very good about semantic meaning. If you just say, describe an area of application, if you don't know the name of it, if you describe, where certain business rules or validation are, that's semantic meaning, and using Codebase can assist with that. But again, agent mode's very good. A constraining scope. A lot of folks don't think of that. They think in the terms of what can I add or what can I use, but also providing guardrails about what not to use, what to stay away. This is also important, again, kind of in that code smarter, not harder with GitHub Copilot, is cutting it off at the pass and saying, don't use this area, confine it to this. It's also, again, it adds all the things I've already talked about for efficiency and latency, and when you think about billing and being most efficient with your token usage, but also the output being the most accurate. Sometimes having those files open, specifically the one that's most immediately on the screen, having something that's relevant to what you're looking at. And then again, we might use all of this put together to orient ourselves before asking for changes. We're not, again, I've said it before, the best way to approach this is to understand. These are very powerful tools. So sometimes in demo mode, they can just go off the rails and say, do this and do that. But when you're in a production mode, and you need to be surgical and tactful about what you're doing, these things become very important. So let's go ahead and start by looking at unfamiliar code and how to orient ourselves, because again, a very standard operation that we would be doing. So I have an application and a repository called the Engine Analytics Web App. And regardless if you're using these features inside of Visual Studio Code or Visual Studio, so they're going to operate similarly in how they are. The one thing I'm going to primarily focus on this repo being used in Visual Studio Code today, but I did want to bring up Visual Studio just to orient folks that Copilot is available. The features there that I'm talking about today with, agent mode and ask mode, the different models that are available for selection, But the important thing, if you're a Visual Studio user of this particular IDE, is to keep it up to date. Visual Studio Code will do it on iteration a little bit more automatically typically, but with Visual Studio being a little bit larger of the ship that it is, typically what you'll see is this little notification icon. There'll be an update because GitHub Copilot gets updated along with Visual Studio. So it's important to keep it up to date, to have the newest features available so that you can use Copilot in there. But again, I'll focus most of this today on Visual Studio Code and this Engine Analytics web app. Just for some reference, I'll do a quick show of what this application actually is. The idea here is that you can enter in some performance metrics and calculations, and then it will output some of the different information like calculating engine horsepower or engine displacement or torque based on giving it, again, some of the initial information. It'll do these calculations. Then it will go and you can see these through reports that give the information output. And then also there's an ability to see some weather information for the given tracks, so that way you can put that information in associated as well. I'll just show you one quick example just to show, and then again, this will be the backdrop. So I'll enter in a vehicle here and we'll put in something like a Shelby, and then we'll do a GT 500 KR. So we're trying to figure out what's the horsepower based on its quarter mile time and the weight of the vehicle. So in this case, we can do maybe like 11.4 seconds. When I say submit, and it gives me the horsepower and rear wheel engine horsepower based on that calculation. So we're going to look at the application and how we can use GitHub Copilot to improve upon this. This application is a Blazor WebAssembly application in .NET 10. And so one of the things I may need to do first is, again, I've been put on a team and we're going to go through the different steps of, you need to be familiar with this code base. You've got features that need to be done. You may even have some legacy code. Now, legacy can mean a lot of things. You might have everything from an older technology stack that actually needs updated, or something just as much as legacy, meaning older and maybe not well-written code. So it might be in the newest framework or language, but you need to make some updates to it. Now, again, you can apply all of the techniques, what I'm doing today, on your code base. Whether you are a .NET developer, front-end developer, a cloud developer in .NET, DevOps developer, it doesn't really matter. These techniques can transcend all of those. So just make sure that you're seeing that. So even though this is applied, you can take it up at a higher level. So the first thing that I want to do, again, is get oriented with my code base and some of what's going on here, because I'm looking and I see a bunch of different projects and folders, and maybe, again, being that this may have been created several years ago and gone through some modernization, there may not be a lot of documentation. I see a README there, which is always good to start with. But here's one: explain this repository structure, identify the main application projects, shared projects, and test projects. This is always important, and the way that you do this, you can ask, layers of specific questions. So what it's going to do is go through and, again, get us oriented, because we don't always have architectural drawings. We don't always have, extensive write-ups. The information can be fragmented across. Now, you might look at this prompt and say something like, is this a bit broad? Could I narrow it down so that I can get oriented with this code base a little bit better? And the answer is yes, you could absolutely do that. But I want to see some of the information that it's coming up with. And it says, first of all, understanding that Copilot will reason through what's being asked. So a lot of the first things that, again, that you'll see, you may have glazed over them before, is it's thinking through, okay, I need to inspect what type of project, what's going on. And it goes through and it says, all right, we have a solution. We've got the UI, the components, shared, and tests. Looks like we're standing on decent ground. As a developer being added to this application, I know, and with some familiarity, let's say on Blazor and .NET in this particular instance, I go, okay, I can look at this. It's not all monolithically, pushed into a single project. We have some separation of concerns. I think this is good. Then it breaks it down. Where's okay, we've got the main host application, our component library, some lazy loaded assemblies, some shared, maybe cross-cutting concerns. Good. The light bulbs are starting to come on. I've also got a mix of X unit and B unit. Plus, it looks like maybe some code coverage within this, and then other top level folders. Now, again, you can take this on to any additional line of thinking and learning that you need. For example, based on the README and solution structure, explain what this Blazor WebAssembly app does in a developer-friendly terms. Great. I've got kind of the technical rundown, but how do I understand what is it actually doing? All right, my lead told me has something to do with engine analytics, but I want to understand more. Think about business rules, layered applications, and all of that. You could be working with tens of thousands or hundreds of thousands of lines of code. So you're going to take this same type of drilling through and asking Copilot so that you can build up a good knowledge base. An anti-pattern for anybody, whether you're 5, 10, 15, 20-year plus vet of software engineering or technology, the thing you don't want to do is just say, AI makes me, super powerful. I've got the issue from the board. I'm just going to go straight to agent mode and execute. I haven't worked with this, this repository much, but I've had good success. I'm just going to go straight to making code. That's an anti-pattern. You know what you're doing. This is a very important step. So going through this tells me it's client-side Blazor WebAssembly app, and it goes more into the kind of in business terms what it's actually doing. This is where we could learn about some of it. You can also ask about the gotchas. You can drill down into that. So you can see this flavor of the information that's coming back. So we know that, again, we have some horsepower and torque, and that seems to be kind of one of the primary areas of the application. Maybe you're working on a customer app, healthcare, finance, human resources, anything, internal, external, again, back end, any of the types of line of questioning you can do. And we'll do one more iteration because we want to drill into this. Find me the main areas where engine calculation, weather tracking, reporting, and local storage appear to be implemented. So now that I kind of know maybe some of the main pieces of the app, I want to understand. Again, it's not ideal just to go straight to agent mode in an unfamiliar application because you're still the pilot. You want to understand what we're going to be looking at, like where are the areas so that when I do start updating code, I have a familiarity that I can say, yes, this is in the right spot, or no, because it happened in a vacuum, say, I don't know, it looks good. Let's just rubber stamp it. Again, another anti-pattern. So good Copilot usage starts with orienting yourself in the code base before you start to change code. So again, it's reasoning through, thinking through where and finding this. If this is a larger code base, this process here is going to take a little bit more time. So keep that in mind because as I'll show you patterns, you may want to drill in and say, all right, give me the main business logic areas within the components project specific to these different areas. And then on a subsequent ask, you might say, and then tie that in to where it manifests in the UI. Again, take that to whatever technology stack that you're working with. And such, it gives me all the areas. Engine calculations, where are the formulas? Good, I know I've got a service, the flow, some of the torque through it, where's the weather tracking, and how does the reporting? So I can be, continue to ask questions on data flow and such. So this is a good start to orient ourselves with what we're using here in our application that we've been assigned to. Now, again, the way we prompt and the way we communicate with GitHub Copilot may be paramount in all of the, work smarter, not harder when you're working with AI tooling. So it's a key skill onto its own. Yes, you can be broad and just say, do this or do that, or try to, I even caution against taking directly from the task board, whether in GitHub or ADO or whatever tooling that you're using or Jira, and just copying and pasting into agent mode and saying, go do this. You have to understand what you're looking at. Is the way it was written by a business analyst or an architect or a lead, going to translate into GitHub Copilot effectively. So you, the engineer, the technologist, needs to take that. Sometimes it may be written well enough. Other times you may need to massage that. And then even more often, you're not going to have something to start with. You need to come up with that prompt. Obviously, being specific is helpful, guiding it through that path. I talked about context before, a key fundamental element in getting a accurate yield from your prompt. Providing those guardrails. A lot of folks don't do that necessarily, about keeping it on task and where to stay away from so that Copilot can be efficient in its use. It also is a good technique to iterate through. Trying to create the end all of prompts that's 15 pages long to do one technically task, even though it might have multiple steps, may not be as efficient as going and doing something, and it will iterate through and do that, but then reviewing it, refining it, and then moving along and iterating with it. Yes, agent mode can work autonomously too, but if you end up having 78 files generated, we still need to audit that. And a lot of times in demo mode, people glaze over that. You have to look at that code and understand it and continue to go through. Stating your intent, again, what you want and what you don't want. That can be technology-based patterns. Maybe you're doing object-oriented programming, functional programming. These skills are still important, and not just letting Copilot always decide. You still have that strategic thinking to guide Copilot on it. And then ultimately, we need to review what code is output by Copilot and what is generated. So the way we communicate, provide content, provide samples, and what to do and not do will help us on our journey when we're working with our code. So let's go ahead and look at refactoring some of that calculation logic within the repository using some of these skills that are just talked about here. So let's jump back into the code base and take a look next at some of this. So let's open we saw that we had the engine calculation service, right? In fact, if I wanted to from up above, I could click on it here, which would open it directly. But I was going to use that just to know where the breakdown was. But we can either click on it if you're trying to, showing you that we could go from the explained, what's come out of Copilot into, and here it is right here. I could just do that. That was like kind of a shortcut, or I could have found the file itself now that I've oriented in the code base a little bit. So I'll give myself a new session here with GitHub Copilot, and let's take a look at some of this code right here. So within this service, we have an interface defining some of these different methods, it appears. So we have engine horsepower, displacement, torque. We saw that in the application. Again, we got oriented. Now taking a look here, we have, those calculations based on the input metrics and data that have come in, which looks to be this horsepower model right here. And the same thing with displacement and the engine torque. We can see similarly that these calculations are being done, excuse me, but not directly in a component. For those of you that do any kind of web development and things like that, that's the first thing we have that we can tell that this has been developed at least slightly well, because we're not directly in a component doing business logic and things like that. Remember, we need to keep those skills about us even when working with AI to understand, because we want to drive Copilot to use the patterns and practices that output the best possible application. So let's start with asking Copilot. We'll continue in here. Now that we've drilled into a file, explain the formulas used in this service, identify any assumptions or edge cases. Again, it's really important to understand the code that we're looking at. So I can see it, I can read it line by line, but I'm going to speed that up and again, work smarter rather than the old school method of understanding it from scratch. I'm going to look at it and see with Copilot, pair up with it and say, explain this to me and what we've got. So, but one of the nice parts about this too, is you notice I didn't just say explain this. I also said identify any assumptions or edge cases, and let's see what it comes up with that. So it's looking through, and here now it's explaining the different formulas that are used, which is good. It's giving me how is the horsepower calculated, how is the engine displacement calculated, and how is the torque calculated, so I can have a better understanding. Again, you might have a business rule that is going through and saying, validate the order or the customer, make sure the date is in range. Does the supplier have, all of the inventory in stock? Anything, any domain that you're in, understanding it is important. It goes down here, edge cases and caveats. Is there anything that we need to look through? Negative values are not consistently blocked. Looks like we might have some things that need to be tightened up here a little bit. Comment says 15% drivetrain loss, but multiplier does not equal dividing by 0.85. So we have to see. I can map these to edge cases, concrete validation rules. I always like when Copilot helps us along because we could grab on to that last sentence and continue on if we needed. So the next thing, it looks like maybe we've got some magic values and some things. So I'm going to say suggest some constants or helper methods that would make these calculations easier to maintain. So sure, looking at this again from a perspective of what's being provided to us in a real application, but this is not uncommon still. And you might be thinking, well, can I just throw, again, jumping ahead and foreshadowing, let me just throw agent mode at it and just say, improve this class and make it better. What does better mean? Things like that. We still need to drive. These are like using Copilot, again, from a lens of real world, looking at code and things like that. So looking through this, it says, this is a great candidate for cleanup. The biggest maintainability wins are removing magic numbers, centralizing repeated logic. I agree. By the naked eye, it looks like that's for par for the course. We need to clean that up. One source for truth. Here's some suggested constant names. Easier audits, probably improve for unit testing and such. Avoid silent behavioral drift if the rounding rules change. And it continues to go through and also justify why. And I think we've moved so quickly in the last 2 to 3 years, again, with AI tooling, that we need to still incorporate these patterns and practices into how we do. Don't just execute. Learn what you're doing. Then you can start to move to, say, agent mode like this. Now we could say, let's go ahead and do some of that. Refactor this service for readability without changing behavior, using suggestions for reducing magic numbers. Keep the public interface the same. This is another important tactic. We don't want to break the callers of the code. Now, another step you could have done, given the time I have to be more brief, but one step that I may have included as well would be, give me the data flow paths and who are the callers. Because if I only have one caller, and I want to make a heavier refactor, including changing the interface for better coding, then I could potentially do that because maybe that footprint is a lot smaller. But if there's, 28 calling points and it's a lot of tentacles into the app, again, can we use, agent mode and have it update all 28 points? Yeah, absolutely we can. It's excellent from that power standpoint, but we also could make a lot of mistakes. So again, being in charge of what you're looking at is key for how you're using Copilot. So it's going through right now. We can see some of the changes. Again, as agent mode continues to work, how many files have changed now? We've limited to this particular file, but maybe I would have needed to touch many other files that could have been in play as well. But we can see immediately it's refactored out some of those magic numbers into local consts. If I was using these across files or services, I probably would even bring that up a level and start thinking with Copilot about using one of those cross-cutting shared libraries to put those numbers in an even more centralized place rather than just the definition and class. But you can see how our knowledge and understanding of the application is still key when working with Copilot to help drive the code in the right way and not being fully autonomous and just saying, refactor this and whatever it does, we rubber stamp. That is not a good method of proceeding forward. So it's going through, it's building, and it looks like that there are some errors. So one of the nice things is that it will see those, and if there are any changes that are needed, it would have updated that. So it says refactor complete. I only updated internals in this, kept the public interface unchanged. And what changed for readability? It's kind of doing some of the things we've already verified visually, replace the magic numbers, behavior compatibility, and the validation status. A tiny pass to rename one helper parameter or something like that. If we didn't like some of the names of these, we could continue on. But one of the other things that you can do is you can also ask on this. So it gave us a synopsis, but you know how Copilot has the ability to do a pull request review, and you've gone through and used Copilot directly in the IDE, right? And you've tightened it up and you've made a pull request and you've shipped it out, and then Copilot does a review and it finds more things, and you go, how come Copilot didn't find that when I was working on the code originally? You probably thought about that, whatever, let's just look at what Copilot said. You can do the same thing and not wait for that. Like right here, review the proposed refactor and identify any possible behavior change. I'm not asking for anything, errors or anything, but I could say best practices and things like that to have it continue to do. So it's going to do a code pass on it, specifically seeing if there's any behavior deltas, and it probably provide any additional suggestions. So one of the important things is always be pragmatic. If it doesn't look right, say so now. Again, you're the decision maker. And all those steps that preceded this were important, that we wanted to make sure the application, we understood it and what we're doing. So it goes through and it talks to us, it checks each public method. It makes sure that they're sound. There's no explicit regression assertion here for edge values. That's something that we could move along with, etc. But also it's saying some nuance here about build verification was blocked by file lock in the UI updater. Let's go ahead and stop the application just to ensure that there's nothing blocked if it's having any issues. But we'll go ahead and keep that code, and let's continue on with moving through our presentation and what Copilot can do for us. So we made some changes, testing. Now, a lot of people have probably already used Copilot and just say, create test, but we want to take it to another level and again, understand exactly what we're doing. So yes, we can improve on tests. We can generate new tests. We can use any framework that's needed. We can also modernize the framework or switch if needed, because oftentimes development teams and such have moved from one framework to another. As time evolves, different unit testing frameworks are better or more favored. That is something that you can do. Whether you are working with very complex code or run-of-the-mill, looking at code coverage, this particular app has decent code coverage in the 90+% range, looking at the output. But sometimes, depending on the framework and technology you're using, those coverage reports can have some blind spots. So it's always good to work with Copilot and see. Blind spots even meaning beyond what the visual in the coverage report. Again, we want to fill those gaps, name what we need to do, and let's go ahead and look at improving some test quality. So I'll jump back over into our application. Let's give ourselves a clean slate here. And one of the things I want to do potentially is start with the coverage report. So I'll open this here and let's take a look at what we were looking at. Like I said, it's above 90%. We do have some gaps, but again, depending on the technology stack you're working with, especially like Blazor, and how the code is built, generated, and then coverage reports hit it, there can be blind spots sometimes. So it's important to understand that as an additional level. That's a pro technique, understanding and not always taking this verbatim, but it's a good data point, a good window into the code coverage. So we can see what we're looking at here. Now, one of the things that I might start with as we look at this, let me open Copilot back up, is I'm going to say review the coverage summary and suggest the most meaningful test targets. Prioritize tests that validate behavior, not just code percentage. A couple things on that while we continue to look at this code coverage report to identify. So we're using Copilot as a partner to find some of those blind spots or gaps and find meaningful tests. Anybody who's been working as a software engineer for any amount of time understands the difference between a good test, what targets behavior, logic, business rules, and maybe a poor test. That would be like the latter. Poor test might be testing getters and setters and things like that. I always say you can have a code file that's 100 lines of code, and if 90 lines in theory were getters and setters and 10 were a block of business logic, you could write tests to cover all the getters and setters, and somebody from a distance would look at a report and go, that's 90%. But the real important lines, the 10 lines of business logic, aren't tested. That's where it's important to put your eyes and Copilot's eyes on this to find out where maybe some of those gaps are. And so what we can do here is let's continue to look at some of this report here, and I'll just give a little bit of more real estate there. And again, you can jump into any one of these and see where some of those code coverages gaps exist. Also, one of the other things that you can do is if you don't have code coverage implemented in your application, it's a great way or a great thing for Copilot to help you on. You're able to ask it, use a mainstream code coverage utility, add it to this application, and then probably in addition to that, show me the documentation, because that's another trap folks fall into moving quickly with AI. Just say add code coverage, and then they don't actually understand what was added, what NuGet package, how to run it, how does it work, and things of that manner. So Copilot is coming back with some information here that I want to look at while it continues to generate. It says, I've isolated uncovered branches. And it says top behavioral test targets, lazy loading. So our lazy loading, which is right here, is one of the projects. And failure handling, it says the highest value. This controls a runtime. These are important pieces of information. We're not just blindly looking for red in the coverage report and saying, write a unit test. Let's understand what is actually needed in our application. So we can go through and use Copilot, and it's explaining what do you want to add tests for. Also, it says weather component robustness for real world. So it's got some of the different pieces here, looking through whether we want the lazy loading or the non-weather routes, some of the additional ones, kind of giving some of that. Add test for empty weather array, why it matters, existing tests, calculation form correctness, not just submit succeeded on some of these. And it continues to go through and ask some of this. So, and then it also identifies lower value coverage gaps in some of the different files. In quick summary, overall line coverage is strong. Branch coverage shows remaining risk. The most meaningful gains come from navigation, lazy load handling, and report edge case behavior. So we're going to take one of these and say, let's add tests for the, and I'm just going to copy one of these report behavior scenario. And I'm going to do what I talked about earlier, stick to this area only and no other tests for this improvement. And the reason I gave that in this guardrail here is because the testing portion of the application can be very large. And so I want it to stay focused on a particular given area. And so now it's going to go through and find which of those files that it should do. So let's look into our test project here. And so you can see that from our test project here, we do have some layout of our different area for each of these. So you can see we have the UI tests, we have the component tests, and we also have the shared tests. Now, these are mirroring the folders in their partner project that they're looking at. So if you look, you should be able to find that quickly. So it's going through and it's going to add those particular tests. And so it's showing you, again, you can always inspect this while it's working. For example, we could open the new or the weather current component test, and it will take us to that area. Start to see what it's working on. When wind data is missing, I like this. Does not, let me get the scroll bar here, does not render the weather card. This is a scenario. A lot of times this, when we're talking about comprehensive testing in our application. It's those edge cases. And again, if you look at how we did this, we oriented ourselves, then we executed. We didn't just say find edge cases, write unit test, push a PR, and then move along. This, as Copilot, I would say, is one of the strongest takeaways about using this tooling, because again, it's so powerful and it's helping us be so much more productive, but we still need to have our fingerprints on understanding what it's doing. So using these steps, learning how to prompt and inquire about this are very important steps. And also the auditing of what we see that comes out. So it says, I finished focus test additions. I'm checking targeted test output. It's obviously going to run the unit test for us, and it will go through and make sure that they work. If they don't, then it can continue to iterate on that and make further changes. So if we go down, and so the first run only reported project build failures without diagnosis. I'm focusing on .NET test commands for the 2 affected test projects to surface the exact failure. Again, it may have been running into some locked files and such. I could probably relaunch the IDE, but I like, and what is important about what Copilot's able to do for us is, again, to iterate through, to see that through until that succeeds. So now it'll use a different manner of making sure that it can run the unit tests and then work on if there are any failures. Also, again, you're always in full control about keeping or continuing on with undoing some of the changes that it's made as well. So it continues to go through, fix the UI, compile. It's only rerunning that one project, confirm the new edge cases, and it does this very efficiently. And we can see it's using the same style that I like as well, which arrange, act, assert, to follow in line for the different pieces here, and making sure that the unit tests are using the same framework and what I had done as well in my format. So it doesn't look like the code that it's building is foreign to my application. So we'll let this finish up here, and then we're going to move on just in a second here to migrating some legacy code. And so it gives us a synopsis here that says it's implemented only those reported edge case test environments, no unrelated test addition, added it through, unit test pass, UI test pass. I can do run a focus coverage report, etc. So we'll go ahead and keep these changes and we'll move along. Let me go ahead and close some of these out, and we'll give ourselves a new session. So I just mentioned, so now we've kind of iterated through. How about legacy modernization? Probably one of the biggest things that we'll do with AI tooling and GitHub Copilot. So again, a lot of times folks don't want to touch legacy code. It's an older technology stack. Maybe you're going from .NET framework to modern .NET, or just as I mentioned, it's something that wasn't written well and older. So we can use it. We can explain code, business rules, how something's working. What are the older languages? Coming up with a plan to then, modernize a very large application. Now, if you're talking about Visual Studio, there's even a specialized modernization agent that you can use, but you can also work with the different tooling directly in GitHub Copilot to inquire and use all of these steps as well. Then we can refactor, document. One of the best parts about modernizing, where there was no documentation, whether that's in code with commenting, actual documentation and readmes and things like that. The spider web of business logic of thousands of lines of code that some developer wrote 12 years ago, and it's a house of cards. Nobody wants to touch it. Breaking that down with Copilot, making meaningful refactoring. And I know what folks are thinking. Nobody wants to touch that, not even with AI, because if it breaks, it can, cause a seismic impact to the business and such. But that's why the steps I'm showing you today to work smarter is important, so that you understand what you're looking at. Also taking small steps. This is important. And of course, you can always experiment with this, but testing that we just looked at is important validation. If you're working with legacy code and there are no unit tests, a good practice with GitHub Copilot is to write tests against that without changing the code. so that you have a goalpost that you know isn't moving if you're refactoring code. That's very important. Some folks don't think about that. They go, I'll just modernize it, then write the test. Well, because it's easy enough with Copilot, we can actually write those tests first, targeting legacy code. Yes, you might be doing some rework, but it helps ensure that safety, that you're not going to modernize code accidentally. That shouldn't be the way you wanted it to. So we're going to go into our application again. And I have something here, this CSV importer. And so this code, if you look at this code here, and we'll take a look, it's got, even just looking at it with the naked eye, let's go ahead and start Copilot on it. So we'll say explain using this here, and we'll make sure that we are in ask mode for this one. We'll say explain this validator. So we got a validator here that takes some CSV content, but it's really rough. It's hard coding values, particular row values. I mean, business logic and magic numbers, definitely written, excuse me, in a legacy aspect, but at the same time, probably very specific about that format. And if we break it, we obviously could break upstream business continuity, and that's a problem. So with this, we're going to look and see, it gives a rundown of, the setup, the row splitting. It gives me some information of how this works. And I want to understand this before I continue on too far with asking it to do some things. So now I'm going to ask it to do something. So we're looking at it and some of the field validations. The year must be 1950 through the next year. Again, we've identified a lot of hard-coded logic here, assumptions and hidden behaviors. We could focus on any one of these individually, but what we'll do now is say refactor this validator for readability and maintainability without changing behavior. Again, we want to keep that calling interface upstream undisturbed. And so we're going to say that specifically. What I might do as well is pick on or cherry pick a few of these potential real red flags first, and then move through it so that I'm not wholesale. Because working on production code, you might look at a file like this that is 900 lines long, right? So I recognize that, we've only got like 100-ish lines of code. You might have 1,000 going through a legacy CSV importer. And so we need to layer in how we're going to work with that. So it's gone through, we've seen some exporting of const, we're improving some capabilities here. With this, we've taken out the length. Now that's this is the quick cleanup, right? And so we're moving through some legacy code, and it's continuing to move through, and then it's going to give me a synopsis of what it's done. What has it changed? The content, centralized error string formatting into a single helper add error. You can see it right here. Compatibility guaranteed. We didn't change the interface. No compile errors there. And we could continue to iterate on in this as well. So maybe another thing that we might do is something like, harden this calculation service for production safety while keeping the interface the same. Add guard clauses for invalid numeric inputs, zero negative, keep valid input behavior, document each rule in line with brief comments, and summarize any intentional behavior. In the interest of time, I'm not going to execute on this because I want to go to a plan and agent mode, but I wanted to point out here something very important is the, document each rule in line with brief comments. Now, this is as old as time, the whole code documents itself. Well, that might be strengthened with Copilot, but we still need to be able to read that code. So meaningful comments about, the why something works is still valid in this way. So I could keep this if I wanted to, and then I would be able to move along with that legacy code. But I wanted to also show you a demonstration on, obviously, agent mode. Now, we've been using agent mode thus far, but how about end-to-end with a new feature? Again, maybe that comes through from an issue, a task, something that's on the board, but also you often will be using this on your own. So we've seen the autonomy that it's working with and fixing errors and moving through, the ability to iterate with it, and that's another thing. But we also want to be able to maybe plan with our code as well. Stay in control. Everything we've talked about before is in play as it culminates to using the most powerful tooling that GitHub Copilot has, agentic development, using agent mode, autonomy, and all of this. So let's see, again, for an end-to-end feature. We're going to come back over here, but this time we're going to start with that plan mode. And so, and again, what did I talk about? We're not in the CSV validator, even though I don't want to muddy the context with something I'm not working with. So I'm going to just start with a blank slate. Create a short implementation plan to add power to weight ratio to this app. Identify the models, calculation service, UI components, and tests that would need to change. So we've seen that, business rules in this application, we have engine horsepower and torque in some of the different areas, but we need to follow that data flow, right? We saw from the beginning it was intricate. It had manifested in the UI. We worked with that interaction, but we also saw that there were layers of services and reporting. Does the weather incorporate into that or not? We don't know. The lazy loading, the shared cross-cutting concerns. I want to see what this looks like in a plan first. And so we would go through this and be able to see. Now it's going to go through, and again, kind of using the semantic capabilities. I've kind of explained generically what the business rule I want is, but it's going to go through and now look at the application and see where those existing business rules and business functionality exist, and then continue through it. So it's going to map out horsepower, torque, and displacement, and it's going to create a plan. Again, sometimes folks say, what's the difference between plan and ask mode? There's some overlap conceptually in that we can ask questions and ideate over things, but plan mode is, again, more of a concrete way with, the virtual whiteboard to go through this. In fact, it will store an in-memory plan for it that's kind of like a checkpoint of what you want to do. And so it's going through, finding architecture snapshot, reading through any documentation, and it's writing a execution plan. So it goes through. Now, one of the things that we're going to do with it, read the plan, see if it fits what we want it to do, and then we can continue to curate that a little bit. So it created, as I mentioned, that plan memory file. Now, you're not always going to interact with that directly. We were probably most likely going to iterate conversationally with GitHub Copilot. So it says add power to weight, first class metric, mirroring. I love it. I like what I'm reading. Mirroring the existing pattern. That's what I'm looking for. What steps is it going to do? Add a new domain model. Make sure it comes into a component, the UI pages. Likely calculation services to change. That's spot on. These engine calculation service, we already refactored some of that. That's where the key metrics were. So that's good that it knows it's going to need to do that. Likely tests that may change, verification. You'll notice here, we can start this implementation. We can go into CLI, we can delegate, autopilot, but you also, as I mentioned, we could just toggle over to agent mode and then specify exactly what we wanted to do. Now, I'm going to wrap up here in a minute, but maybe I want to add this to an existing model instead and using the existing pattern rather than creating a lot of new files or something like that. So I can further refine that pattern and just put something more tactical and surgical for it. So we're seeing how, again, from plan mode to agent mode, and then again, agent mode being able to use that autonomy with that plan to then implement what it's going to do. So it's going to make a straightforward, minimal implementation, and that being in the interest of time. You will see that agent mode sometimes can take several minutes or longer. That's normal depending on how large the scope that you're working with GitHub Copilot. If that's of any concern or it's doing too much, that's the caveat for delegating to kind of a black box, because you're going to have a lot of code to review. So you'll have to walk that balance of being tactful and getting things done and also getting things done in mass. While it's a cool flex to delegate to a cloud agent or just do something in wholesale, it's not a flex if you submit something in a PR that sneaks through and breaks functionality because you didn't actually understand what the code was doing. Then you're going to end up having to fix that later. And so it's going through and we can see what it's adding, the calculate engine to power weight ratio. It's going to go through, make sure it builds and continue on, and we can finish that piece of functionality. All right, so we've seen a lot in a short amount of time, wrapping up there. So what are our key takeaways for today? I've shown from the beginning, context is paramount. Make sure that the way you're describing your prompt or what files you're giving it explicitly, however you go about that, will bring Copilot in for more accurate results. This is a big one. And again, this is something we may have veered off the path a little bit, but orient before you act. Understand what you're doing, but you can use GitHub Copilot smartly to bring you up to speed at a fraction of the time that it would have taken pre-having tools like that. Again, we can iterate, make sure that it works. Even with agent mode, you take a piece of functionality or multiple pieces, validate. This is what branches and commits and all of those things are for, so that you can understand and you're not coming out with 83 files and going, I don't know, looks good, rubber stamp. You are the pilot. That is that piece of it there. Agent mode is the future. It continues to get more and more powerful. So use all of these techniques that I've shown in addition to what you have already, and you will use GitHub Copilot most smartly and cut out the hard parts. So with that, I'll double check on any questions, but I want to make sure before folks leave to make sure to check out the other AI Skills Fest sessions going on this week, not only from Xebia that we are partnering with, but the greater scope of what's at AI Skills Fest. And make sure to showcase your new skills. You can get your exclusive badge right there. I can put that into the chat to make sure that you have it. If you're on the socials, you can put there the hashtag AI Skills Fest. Talk about it on LinkedIn or Blue Sky, Twitter, whatever you end up using, put and talk about it, share the experience about my session today and the other sessions that you're going to. Again, let me put that in the chat for you here to make sure that everybody has that. And I will do a quick look and see if there are any questions that I could rapid fire answer. There we go. And so is fitting metaphor AI giving it a broom? Yes, human only, human. Yes, going through sweet spot, staying in phase 2. Love the understand, thinking better. This is very good. Yes, trust. Yeah, great points by the audience there. And I did put that link for your badge. Any other questions before we conclude here today? Oh, fantastic. I appreciate that from the audience. Again, enjoy AI Skills Fest the remainder of the week. Go use GitHub Copilot, use the techniques and skills that I showed here today to use it to the best of your ability, and you will be successful in your technology journey. Again, thank you for everybody for being here today, and I hope you have a great rest of your day. Take care, everyone.
Thank you, sir.
Thank you.
Thank you, Alan.
Thank you so much. Was there a question,
Thank you,
Paulette?
Alan.
Thank you. Oh, no.
Sorry, that was an accident. Thank you so much.
No problem. Thanks for joining.